Welcome to The Explainer. Today, we are digging into one of the biggest questions in all of science. What in the world is the invisible force that's literally pushing our entire universe apart?
For the longest time, astronomers thought the universe's expansion had to be slowing down. It makes sense, right? Gravity should be pulling everything back together. But as it turns out, something way stranger is going on. The universe isn't hitting the brakes, it's flooring the accelerator. Okay, so let's get right into it. To really wrap our heads around this, we need to travel back to 1998. This was the year that our entire understanding of the cosmos got turned completely on its head.
So get this, two totally separate teams of scientists are out there using these special exploding stars, supernovae, as cosmic measuring sticks. But the data they started getting back just didn't add up. The supernovae were way dimmer than they were supposed to be, which could only mean one thing. They were much farther away than all the models predicted. And the only possible explanation, as crazy as it sounded, was that the expansion of the universe wasn't slowing down at all. It was actually speeding up.
You can imagine, this discovery created a massive puzzle. If gravity's whole job is to pull things together, what could possibly be powerful enough to be pushing everything apart? Scientists needed a name for this thing, this invisible suspect that was driving the whole universe.
And the name they came up with was dark energy. It sounds simple, right? But the idea behind it is just huge. It's this theory that there's some kind of energy woven into the fabric of space itself, a kind of anti-gravity that's constantly pushing galaxies away from each other.
Now, this right here is where things get really wild. Just look at this breakdown of the universe. Everything we can see and touch, every star, every galaxy, you, me, this planet, all of it makes up just 5% of reality. A mind-blowing 68% of the entire universe is this invisible, mysterious, dark energy. Think about that. We're living in a cosmos where we can't even see the number one ingredient.
So you've got to be asking, if we can't see it, can't touch it, can't measure it in a lab, how are we so sure it's even real? Well, the case for dark energy isn't built on just one thing. It's built on a whole file of evidence, with clues all pointing to the exact same strange conclusion.
The case really comes down to three key clues. First, you've got those supernova observations we talked about, the original smoking gun. Second, there's the cosmic microwave background. You can think of it like the afterglow of the Big Bang, a baby picture of the universe. And the patterns in that picture only make sense if something like dark energy is stretching everything out. And finally, there's just the way galaxies are spread out across the cosmos. They're clumping together in a way that shows some huge, universe-wide push is winning out over gravity's pull.
And this wasn't just some wacky theory from the fringes. The evidence became so rock solid that in 2011, the leaders of those two teams that first saw the supernovae were awarded the Nobel Prize in Physics. This was official. Our entire picture of reality had fundamentally changed.
Okay, so let's get into the mechanics of this. What's really happening out there? The best way to think about it is as a giant cosmic tug-of-war, a battle of forces that's been raging since the beginning of time.
So here's the bottom line. The entire fate of the universe hangs on the outcome of a fight between two forces. On one side, you've got gravity, always trying to pull stuff together to build stars, planets, and galaxies. And on the other side, you've got dark energy, always pushing all of that stuff apart. And right now, it looks like dark energy has the upper hand.
And the wildest thing is, our best guess for what dark energy is actually came from Einstein himself. He had this idea called the cosmological constant. It's the notion that empty space isn't really empty at all, that it has its own built-in energy. The funny thing is, he came up with it to make his equations work for a static universe, and when he found out the universe was expanding, he called it his biggest blunder. And now, all these years later, his blunder might be the single best explanation we have for why the universe is accelerating.
And this is where the physics just gets wonderfully weird. To describe dark energy, scientists use this value they call W, and its value is around -1. Okay, so think about it like this. Normal pressure pushes outward, like the air in a balloon. But negative pressure, that creates a kind of tension that actually pulls space itself apart, making it expand faster and faster. It's a truly bizarre concept.
So, who wins this cosmic tug-of-war? It's not just some academic question. The answer is literally going to determine the final chapter of the entire cosmos. It's how the whole story ends.
Right now, the most likely outcome is something called the Big Freeze. The idea is that if dark energy just keeps on doing what it's doing, the universe will expand forever.
Galaxies will fly so far apart they'll disappear from our sky. Stars will burn out, and eventually everything will just fade into a cold, dark, silent emptiness.
But what if it gets stronger? Well, that leads to a much more violent end called the Big Rip. In this scenario, the accelerating expansion becomes so powerful that it overwhelms everything. It would tear galaxies apart, then shred stars and planets, and in the final moments, it would rip apart the very atoms we're made of.
And of course, there's always the old theory of the Big Crunch. Now, dark energy makes this a lot less likely, but it's not totally off the table. It's possible the nature of dark energy could change someday, letting gravity finally win the tug of war and pulling everything back together into one final spectacular collapse.
So, why does any of this really matter? Well, because this isn't just some small detail. Dark energy is the main driver of our universe. Understanding it is the key to knowing where we came from and where we're going. It's a direct challenge to our deepest understanding of physics and a humbling reminder that the biggest piece of our reality is still completely hidden from us.
In the end, this whole mystery leaves us with a pretty profound realization. We live in a cosmos that's not just stranger than we imagine, but one that is expanding faster than we ever thought possible, all driven by a force that we are just beginning to comprehend. The biggest secrets, it seems, are still out there, waiting in the dark.